And welcome back. Today we're going to take a pretty common item, a 2-liter bottle, show you some interesting things.
Ted Keller, our science feller, has another show and tell for us. This one looks very interesting.
Yeah, a lot of soda.
Yeah.
I had to drink a lot of soda to get this to work.
That's your commitment to science,
that's
right
my
there.
commitment to science. And this has to do with pressure and, of course, 2-liter bottles. And we already demonstrated right before we came out to the commercial break about this is a very common experiment. This is the tornado in the bottle. But before we demonstrate that, what I'm going to do is just turn it over. And we've done this earlier, and you just let it sit there. Nothing's happening.
Much.
Right.
We got a stalemate. Because the air on the top and the air on the bottom are under equal pressure, and they are just crossing arms, and they can't get anything done.
So we have to change the pressure.
They need a therapist.
Yeah, they do. They do. But I don't think we can get one in the bottle.
No,
so let's go on to this, the next possibility. Who wants to give it a swirl? Try giving it a swirl there and see if you can do the tornado thing. All right, here we go. What we're doing, give it a more exaggerated twirl, like a top. There we go. Yeah, I think you got it. Now what we've accomplished is we've given the air a pathway from the top to the bottom bottle, and now we've got an efficient way of transferring the water from one to the other. If you ever clean out a big container like a glass carboy, give it a spin. You'll save yourself about 2 or 3 minutes of draining the water.
Yeah, absolutely. Now, is this also the way kind of a tornado works? Is that a transference of pressure or anything?
Yeah, when we turn this upside down like this, we created potential energy. We have the water sitting there, and gravity really wants to give it a tug. And in the atmosphere, you are creating potential energy, and usually it's in the form of warm, humid, unstable air near the ground, colder air aloft. In this case, the twist that you just gave this is an updraft and a thunderstorm and local winds that want to do that. And when you have this kind of efficiency, it's often the best way to transfer energy. Some of your most violent tornadoes do that.
Right. There it is.
There it is. And by the way, I just put a lamp oil in there and a few floating
so you see the idea of debris and everything. Right.
Okay, well, let's get another.
All right, let's move this
2-liter bottle out of here.
Okay.
Okay. Now
I'll move this over
here.
I'll be back.
Okay, that's right.
Take your time.
Tom, go ahead and grab that
all right.
bicycle comb. We're going to make top the muscle here.
All
right.
That's right.
Okay.
Now, what we're going to do is we've got a cork put down on the top of there, just kind of fit it. And Shannon, what I want you to do is hold that cork in place no matter what it wants to do.
Hold the cork in place.
Yeah, or just push it right there, actually.
All right.
Like right there. And then Tom's going to pump.
Okay.
I think we have to give it about 5. Now, what do you guys think is going to happen after we force air into here and Shannon lets go of the cork?
I think it's going to explode.
I didn't bring the safety glasses this time.
No, you didn't.
Now, just I'll hold the bottle, Shannon. You pull it out.
Oh!
Wow!
What have you done there?
What have I done now? That's right. Well, we increased the pressure inside the bottle, and I'll just go ahead and tell you at home, this effect was maximized by putting rubbing alcohol in here instead of water.
Okay.
But the principle is the same. You increase the pressure, and then when you suddenly release the pressure, the temperature drop. Pressure, temperature, and density are all related in our atmosphere, and you can create a cloud inside a bottle. There are alternative ways you could have done this, too. You could have put water in there and blown some smoke in there and put some condensation particles in there.
Something for it to condense on.
And in the free atmosphere, you need that. Even though you think the air is clean, it is not. It's got little tiny particles floating around, and as I just explained to my students the other day, I think precipitation is actually amazing in clouds because there's a lot of little tiny things that have to happen for you to get a raindrop.
We've talked about super cooled air before because it doesn't have anything to condense on.
That's right.
It can actually be below freezing.
Much below freezing, yes.
All right, now coming up next, Ted is going to take a science experiment outside with some young assistants.
Looks like they're out there waiting for you, Ted. I think they have plans to shoot a rocket. Get going out there. We'll be right back with that.